Hello students, good morning to all. I hope you all are fine. So today we will discuss about the topic Hess law. This is also topic of the unit 5 thermodynamics class plus 1. Here what is Hess law? Students, Hess law is also known as constant heat summation. Law of constant heat summation. What do you mean by this? We will understand it today. Hess law states that at constant temperature, heat energy change, or we can say change in enthalpy of the reaction accompanying a chemical reaction will remain constant irrespective of the way the reactant react to form the product. What do you mean by this complicated definition? You will understand this. Student, here it is saying that if a reaction proceed either in one step only, if a reaction proceed either in single step only, or it may proceed in many steps, in a number of steps also. In number of steps also. But what will happen? Let us consider here enthalpy change. When reaction take place only in one step, then if enthalpy change take place there, delta H, then enthalpy change take place there, delta H. We are considering that. Okay. Second way is that the reaction, the same reaction is not proceeding in single step only, but it is proceeding in 3 steps. In 3 steps. So students, first of all, it will complete its first step. So some enthalpy change will be there. We consider that is delta H1. In second step, we consider enthalpy changes delta H2, and in case of third step, enthalpy changes del H3. This law is saying that enthalpy change will remain constant. It doesn't matter reaction is proceeding only in one step or it is proceeding in 2 or more steps. Total enthalpy change will remain constant. Means when it is proceeding only in single step, so enthalpy is delta H here. Enthalpy is delta H. But if it is not proceeding only in single step, but it is going on in 3 steps, so there will be delta H1, delta H2 and delta H3. Then this total enthalpy change will be equal to sum of all these enthalpy changes, sum of all these energies. Means overall change in enthalpy will be constant. Either it is taking place in single step only or it is proceeding in more steps. Okay, so total enthalpy change will remain constant. It is clear to you or not? Any doubt in this? Yes, you can understand in this way also. Here student, let us consider you want to form A to D. You want to form A to D. Let us consider enthalpy change is delta H here. Here enthalpy change is delta H. One is this. Directly you are moving from A to D. One possibility. Second way is this. First of all, it will go to B, means it is giving us B first. First it is giving us B. For this, it used energy or change in enthalpy del H1. Then after B, it is going to C. It is giving C. For this, let us consider change in enthalpy. Change in enthalpy H del H2. Then it will give us D. And for this enthalpy change is del H3. Then student, this total energy, this one is the total energy for reaching from A to D. And these are the energies of every step. When we are not going up to the product directly, we are following some steps. Okay, so this total enthalpy change will be equal to the summation of enthalpy changes of the all steps. It is clear to you or not? Means we can say that total enthalpy is constant here. So now you try to understand the definition. Here. It is known as law of constant heat summation. Means here heat summation, this enthalpy will be constant at constant temperature. What is the condition here? Here temperature should be constant, because if we are increasing the temperature, then there take place change in enthalpy also. So what is the condition we need to follow? Temperature should be constant. At constant temperature, the heat energy change accompanying a chemical reaction will remain constant. Okay, heat energy change will take place during a reaction is constant. It doesn't matter why either reaction is going to be in more steps or it is going to be in only one step. Clear or not? So students, can I say that it is state function. It is state function. Because it is not depending, beta, which path is followed. First it comes to B, then C to D, or directly A to D it is reaching. Doesn't matter. Total enthalpy change will be constant. Clear or no? So this is the Hess law. You can understand with the help of an example. Carbon react with oxygen to form carbon dioxide, releasing 94.3 kilocalorie of heat in a single step. Here you are having, students, carbon. It reacts with oxygen. And to form carbon dioxide. It is forming carbon dioxide. Okay. Then students, carbon dioxide releasing 94.3 kilocalorie of the heat. So here, it is releasing heat 94.3 kilocalorie. Clear or not? Means plus heat. So what amount of heat? This one. Carbon can also react in two steps. This is for single step only. It is for single step. Carbon can also react in two-step process to forming an intermediate carbon monoxide, which again is converting into the carbon dioxide, and del H is minus heat released. Okay, so you can understand this reaction may be in this way. First of all, carbon react with oxygen, it gives us carbon monoxide, means partially combustion take place first. Combustion means burn in presence of the oxygen. Okay, then first of all partially combustion takes place, then this CO, carbon monoxide, further react with oxygen, and then it will give us CO2. Then it will give us CO2. Means reaction can take place in more than one step. Here same reaction, each following two steps. Clear or not? First step, students, when carbon partially combustion is taking place and carbon is converting into the carbon monoxide. So here change in enthalpy, heat released is 26 kilocalorie. 26 kilocalorie. And when carbon monoxide further combusts, then heat is 68.3 kilocalorie. Means either this is the enthalpy for first step and it is for second step. So we can consider it del H2. So here total, this total enthalpy change del H, it will be equal to the enthalpy change take place into different steps. Del H1 plus del H2. So here you can see this one is 94.3 and this is 26 and 68.3. So add this 0 plus 3, 8, 6, 8, 14, 6 into 8 plus 1, this means del H1 plus del H2 will be equal to the del H. Clear or not? This law is clear or not? Okay. So students, in this way, one more example you can see. Hess law can be applicable for the multi-different reactions. Because if there are two or more reactions and we want to calculate enthalpy change for one intermediate reaction for that, so we can do with help of Hess law. So students, here you will try this one. If any doubt you have, then I will explain tomorrow. So thank you. Have a nice day.